In this tutorial we're going to be using the the Biot-Savart law in order to get the magnetic field due to a current loop. So picture a loop, or well, this could be any given piece of arc of a wire which has, for instance, certain current. Okay, and let's suppose that we're going to analyze in this point P, which is at the center of a circle. This is the semicircle, but it's the center of a circle. We're going to take a piece of this circle, of this arc, and if we analyze, for instance, that towards this direction goes the vector r, which is the distance, the vector which is the from the point of evaluation towards the loop, and tangentially speaking the current goes towards this direction in this small piece, and it will happen in all of the rest of the pieces. Then we can, for instance, grab Biot-Savart law, and we can state that this is mu 0 I, so let's put it in a differential form, dl, for instance, which in this case L, I am going to put it as an S since this is an arc, so S, remember, is an arc, in a cross product with the unit vector r over 4p times r squared. And in this sense, ds, which is the small piece of this arc, has the direction of the current, and the angle between the current and the unit vector r is 90 degrees. So in a huge parenthesis, we can say that ds in a cross product with r is, for instance, the magnitude of ds times the magnitude of unit vector r, which is 1 because it's unit vector, times the sine of the angle between both of them. The sine of 90 is 1, so this will yield to ds only. So this differential will be mu 0 I ds. Let's state that there is no more vectorial form, right? Over 4p r squared. And if we do the integral over the whole arc, we will state, for instance, that this is mu 0 I, the integral of the arc is the arc, over 4p r squared. The only situation that happened is that we have to integrate the integral of the differential of arc, because mu 0 I, 4p and r squared are constant in no matter which section I am evaluating of the arc, right? And then we can turn this arc S, and we can state that the arc S, let's remember that S is the arc, which is r times theta, so we can, for instance, state that this is r times theta, and of course we can have one r with one r, such that at the very end the magnetic field is mu 0 I times theta, theta being, for instance, the radiance of the circle or of the arc that we're having. We can have, for instance, p radians, or we can have 2p radians if it's a complete circle, etc., over 4pr. And of course the direction is given by the right hand rule. So you just have to apply the right hand rule. In the case that I am painting, I hope that that you understand that if the current goes in that direction, then in this sense the direction of the magnetic field is going towards the inwards, right? So this is due to the right hand rule, remember? Your right hand rule.